K stands for your equilibrium constant. You can apply it to two different kinds of reactions to get a particular K value. The first one is when you're dissociating an acid and a base. You can write the K value for a reaction called the dissociation of an acid and of a base. An acid is something that gives away a H plus, and a base is something that takes a H plus. So an acid is something that gives away a H plus, it gives it to the base, and the base is something that takes a H plus from the acid. So when we talk about acids and bases dissociating, we're saying, oh, the acid is breaking apart because it's losing its H plus, and the base is also turning into something else because it's taking a H plus. When you write the dissociation equation for an acid, we tend to write it with water, because unless the acid is reacting with a particular base, it tends to just be in solution. And if it's in solution, what it means to be in solution is that you've dissolved it in water. So all you're doing here is, let's say, for example, I gave you an acid, HCl. What acid is HCl? Hydrochloric acid. So when you get a question asking you to write the equilibrium expression for the dissociation of an acid, what you'll do is you'll write out the acid and then you're going to react it with water. HCl is not the most accurate one for us to do this for, because HCl actually dissociates completely. So you don't use a reversible arrow for this. But for the purpose of learning, when it gives away a H plus, it gives it to this guy. So you get left with Cl. And because you didn't just give away a H, you gave away a H plus. If you lose a positive charge, you get left with a negative charge. So what you get left with is Cl minus. And then H2O, because you've added a H plus, it turns into H3O, and then you added a positive charge. So this is H3O plus AQ. So this here is your dissociation equation for an acid. And then the K value gets given the subscript A. So this here is called your acid dissociation constant. You write the equilibrium expression the same way. It's the concentration of products over the concentration of the reactants to the power of any of the coefficients. Once again, I didn't include water because it's a pure liquid. So the only difficulty here is learning to write the equation for the first time. So this is an acid. And then if I gave you a base, NH3, what's NH3?
Ammonia.
Ammonia, thank you. Same thing with a base. When it's in water, it's in aqueous solution. So the thing it's taking a proton from, or taking a hydrogen ion from, is H2O. It takes a H plus over here. So instead of NH3, you end up with NH4 plus AQ, because you take the H and you also take the positive charge. And then H2O, you lose a H plus. It has two hydrogens and one oxygen. If you lose one hydrogen, you only get left with one hydrogen and one oxygen. So it's HO, but we prefer to write it as OH. And then it's neutral, and then you lose a positive charge. So you end up with a negative charge. So this is your dissociation equation for a base. So if it's for an acid, you give away the H plus to the water, you end up with H3O plus. If it's a base, you take the H plus from water, you get left with an OH minus. So this is going to be called KB, and this is your base dissociation constant. So it's just the equilibrium constant. We just give it a specific name so that you know what particular reaction it is, and then you write your equilibrium expression the same way. So this is NH4 plus and OH minus, all on NH3. HNO3 is an acid. What's the name of this?
Nitric acid.
Thank you, nitric acid. And when I'm writing acid or base dissociation reactions, I'm always reacting the acid or base with
Water.
H2O. And we're doing module 5. This is a reversible reaction. And then an acid gives away a H plus or takes a H plus.
Gives away
a H plus. So it goes over here. So if I lose a H plus from NO3, I just get from HNO3, I get left with NO3, and I'm losing a H plus, which means what charge do I now have left over on my NO3?
Negative.
And what's the other substance that I form? H2O gets now given a H plus. So H plus combines to H2O. What do I form on the right hand side along with NO3? Hydronium, what's the formula?
H3O plus.
H3O plus is called your hydronium ion. Your equilibrium expression, what's the little subscript I give it?
A.
It's going to be Ka, and what's the expression?
Bracket NO3 minus H3O plus over HNO3.
So this is your acid dissociation constant. You know it's an acid because H3O plus is getting made on that side. If it's a base, then OH minus gets made on that side.